My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with the Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. Hello, you are welcome to episode number 51 of the 120 Days to Jamb Physics with Flash Isaac. In this episode, I shall be introducing light waves. I promise to make this class as interesting as possible, and it promises to be the best class you will ever attend when it comes to light waves. Ladies and gentlemen, I said earlier that waves are disturbances. These disturbances can either have the ability to travel through a material or through a medium, or they have the ability to travel through space. Which means we have two types of these waves. The ones that require material or medium to pass through, and the ones that do not require. The ones that require material medium, like air, sound, or solid, for them to pass through to propagate, are referred to as mechanical waves. And a good example of mechanical wave is sound waves, which we've already dealt with in the previous episodes. And we have the types of waves that they can travel in empty places, in space, in blank place. They don't need, or they don't necessarily need light or water or solid or gases for them to propagate. They can travel through space. These ones are referred to as electromagnetic waves. Light fall under electromagnetic waves because they do not require material medium to propagate. Apart from falling under electromagnetic waves, waves can also be classified into two based on direction. If this is a wave, if this wave is propagated this way, if this is where this wave is being propagated, if this wave choose to travel in the same direction to the propagation, we say that wave is longitudinal. Sound is a longitudinal wave. If I say hello, this is the direction of production of the wave, and the direction of propagation or movement is the same. It goes like this, to and fro. Then we have the types of waves where if this wave is propagated like this, if this is where the wave is produced, the direction of the wave will not go exactly the same place the wave is produced. The direction of propagation will be 90 degrees to the direction of propagation. So if wave is produced this way, the direction will be perpendicular. In this type of wave, we say they are transverse waves. Transverse waves. So light waves are transverse waves. Waves are disturbances that travel through medium or space, and they transfer energy. They transfer energy from one point to another without mass transfer or with negligible mass transfer. Energy do not have mass and they do not occupy space. So waves, as they travel, they transfer energy. Just like every other waves, light waves also transfer energy from one point to another. And light waves or light are waves composed of discrete particles. Light waves are waves composed of discrete particles. In physics, you can either have a discrete or a continuous particle. Discrete means it has a particular value. It assumes a particular value. It has a particular strength, a particular unit, or it is assigned a particular number. Meanwhile, continuous particles or continuous properties means all those properties, they assume value, they change value with time, they change continuously. But the particles that these light waves are made up of are referred to as photons. And these photons are discrete particles. A photon is a tiny particle that comprises waves of electromagnetic radiations. Now, these photons, they are massless, they do not carry mass, but they have energy and they have momentum. These photons are basically electric fields and they move at the speed of light. Remember, white light is made up of waves or electromagnetic waves of different wavelengths. And the speed of light is 3 times 10 raised to the power of 8 meters per second. This is the velocity of light. And ladies and gentlemen, there are different types of light waves, or you say different types of electromagnetic waves. And this is the shortcut for the different type of electromagnetic waves. They are Ga, Zu, V, Mr. Gazuvi Mr. is the shortcut for the classification of electromagnetic waves, EM waves, or the shortcut for the types of light waves. This is gamma rays. This is X-rays, ultraviolet light, a type of light wave. This is visible light. The light you see around, these are visible lights. Infrared waves, infrared. Microwaves, radio waves. Now, looking at this shortcut, Gazuvi master. From here to here, wavelength is increasing. Is increasing. Wavelength is increasing, meaning here is the shortest wavelength. Gamma rays, they have the shortest wavelength, followed by X-ray and so on. So radio waves, they have the largest wavelength in the electromagnetic spectrum or electromagnetic radiation or in the light waves. Now, there is this wave, there is this formula V is equals F lambda. Therefore, lambda will be equals V over F. This shows that wavelength lambda and frequency are inversely proportional to each other. Inverse means as one is increasing, the other one is reducing. So anytime you hear that the wavelength is large, it means the frequency is very low. And when the frequency is high, the wavelength is small. They are inverse. If gamma rays have the shortest wavelength, it means that they will have the highest frequency. So this is increasing, no, reducing or decreasing frequency. From gamma rays, frequency starts reducing. So gamma rays have the highest frequency and they have the highest penetrating power. And gamma rays and X-rays are the most ionizing. In fact, this part are referred to as ionizing region, while these guys are non-ionizing. In chemistry, ionization energy or ionizing is the energy required to remove an electron from an atom. That is ionizing energy. So this and this, they can pull out electron from an atom. And how does it affect the human life? They can affect the cells. So if you come in contact with X or gamma rays, if not monitored, it can harm you. It can affect your cells. It can lead to DNA mutation. It can also lead to death. Ionizing uh, rays can lead to death. They can actually kill. While infrared radio wave, these are non-ionizing. And these guys are basically the ones used in your telephone communication. So, gamma rays is the electromagnetic ray or a form of light waves with the highest penetrating power with the lowest frequency. And these gamma rays, they are the most penetrating and they have the highest energy among the electromagnetic radiation. They are commonly produced by neutron stars and supernova explosions. They are also used in nuclear medicine, they are used for security, and they are used to treat cancer. And why are they used to treat cancer? It is because of their high energy to destroy the cancerous cells. X-rays, as you can see, are found between ultraviolet rays and they have a wavelength that extends from 10 raised to the power of minus 8 to 10 raised to the power of minus 12 meters. X-rays are more penetrating than ultraviolet rays and they affect the living cells. Me and you know that X-rays are used as for security and in medicine to take photograph of bones. So all these are soft X-rays because strong X-rays can actually penetrate the bones. Immediately after X-rays, we have the ultraviolet rays, UV, ultraviolet. The ultraviolet rays are found just above the violet part of the visible light, hence its name. They are found just after the violet part of the visible light. That is why it is called ultraviolet. They are more violent than the visible light. The wavelength is between 400 nanometer to about 10 nanometer. It is visible to the human eye, but some insects such as bumblebees can see objects using them. It is used in sterilization. Now, just like sound waves, there is limit to the sound you can hear. This is similar to light waves. Not all light you can see. You can also only see light in the visible region. Once it's above the visible region, your eyes can no longer see that wave at all. So this takes us to visible lights. What are visible lights? What are infrared rays? What are microwaves? And what are radio waves? Visible lights, just like the name implies, is the only part of the electromagnetic spectrum that can be seen by the human eye. It is a very narrow range with wavelengths between 400 nanometer to 750 nanometer. It has 6 components of colors: the red, the orange, the yellow, the green, the blue, and the violet. Red has the highest wavelength, but it has the lowest frequency, while violet has the shortest wavelength and the highest frequency. It is mainly responsible for human vision and human perceived lights. The visible light is responsible for perceived vision, is the part that you can actually see. And this is it, Roy Beef. Roy Beef. These are the visible lights: red, orange, yellow, green, blue, indigo, and violet. And I already told you their strengths in terms of wavelength and in terms of frequency. Immediately after the visible light, you have the microwaves. Microwaves. Now, this sounds familiar. You're cooking at home, you make use of microwaves. So, in physics, what are actually microwaves? The microwaves have the shortest wavelength
Pardon, we skipped the infrared rays. Infrared rays are found between microwaves and visible light. This is the term infrared means below red. Infrared rays actually means below red. Infrared red means below red. Why? It gives us a hint that it is found near the lower limit of visible light, and the lower limit of visible light is red. These waves are used in thermal imaging and heating. While microwaves have the shortest wavelength than radio waves, and they have frequencies ranging from 10 raised to the power of 9 Hz to 10 raised to the power of 12 Hz. These waves are utilized in satellite communication. Then radio waves. They have the longest wavelength in the electromagnetic spectrum, which can range from length of the football to the diameter of a planet. These waves are commonly used for communication, such as televisions and radio. That is the region you use radio waves. And they are in the non-ionizing region. They are not so harmful and they cannot really damage you. So this period, this area are the non-ionizing. Wow, that being said and done, let's look at the various sources of light and the various objects. We can have transparent objects. Transparent objects are objects that allow light to pass through. They are transparent, they are see-through. In your phones, you have screen guard. Once you put screen guard in your phone, it looks like your phone is not covered. You still see your screen, your display very well. So that is transparent. It is see-through. Light can pass through it. Even your windows at home, the louvers, those glasses, you see through them. In your car, your windscreen, you see through them. They are transparent. That's one type of object. Transparent. We have translucent. Translucent. Translucent objects, they don't allow light to pass through them easily. Like you don't see through them clearly. They are in between transparent light and another type of object called opaque. Opaque objects, they do not allow light to pass through them. They are not see-through. Your wall is opaque. This is opaque. Your normal light cannot penetrate it. What else? Your chair, table, most of these thick objects are opaque. But this one are some glasses that only small light can pass through. Any material, you see that light cannot really go through easily like that, but to an extent, it can pass through a little. They are translucent. We shall be ending this episode with the transmission of light. Like I've already talked about this, that objects can be transparent, translucent, or opaque. Then we have vacuum. Opaque objects, they do not allow light to pass through them. Translucent objects, they are in between transparent and opaque. Light can pass through them only little. Example, wax paper, your toilet rolls, windows panel, any object at all that you see that once you hold it like this, you will not be able to see the back of or what is at the back, but just small, right? Like toilet roll, pass light through it. You see that light can actually pass through it, but it's not really that see through. While transparent objects, light can pass through easily, like clear water and other examples I gave. Then light can be transmitted through vacuum. The light from the sun to the earth is via vacuum. There is no material medium. And the sources of light are classified into two: luminous sources and non-luminous sources. Luminous sources of light are sources of light that they produce their own light. They can produce their own light. While non-luminous sources, they don't produce their own light. Now, luminous sources of light are grouped into natural or self-luminous and artificial or man-made. Natural, they are natural objects in the world that they produce their own light, while artificial or man-made luminous source of light are sources of light produced by man. Natural sources of light are sun, stars. Stars produce light, sun produce light. Glowing worms, you see they are glowing, they produce light. Even some insects, you see light coming out from their body. Then fireflies, all these are natural luminous sources. While artificial sources of light are your matches, candle light, torch light, electric lamps, and car headlamps. All these are luminous, but they are artificial or man-made. Now, non-luminous sources, they don't produce light. The light or reflection you get from them are from light. Like light shines on them and they reflect that light. Or we see them based on light shining on them. If you are reading a book, you are able to see that book becoming bright or clear based on light falling on that object. So, non-luminous sources of light, they don't produce their own light. Example is moon. The moon that you see, the moon does not have the ability to produce its own light. It is the light from the sun that reflects on the moon. So the moon cannot produce light at all. It is non-luminous. The earth is non-luminous. It is a result of light falling on the earth. That's why the earth is bright. The earth itself does not produce light. Road signs, pages of books, and so many others, most objects are non-luminous. With this, we come to the end of this episode. And I do hope you found it interesting and you found it helpful. Go and get the Flash Learners app. Visit flashlearners.com. You'll be able to see a lot of questions there to play with and to practice. You'll see answers and so many features there that will help you pass your exam with ease. With the series and the app, you are going to score extremely high in Jamb. Every year, I get people scoring very, very high. And those writing Jamb for the first time, they actually get so complacent. They feel, I won't get the app. Let me just watch it. But after failing Jamb first time, they become so serious. It is not a good thing to fail Jamb before you become serious. No, it does not really make sense at all. So, with that, we come to the end of this episode. From the next episode, we shall be looking at propagation of light, rectilinear propagation of light, to show that light travels in a straight line. From there, we look at the pinhole camera and we'll do what we are able to do. After that, the journey continues. Take care of yourself and see you